Anytime you have data that's normally distributed, my advice to you is to make a sketch of a bell-shaped curve, okay? It doesn't have to be perfect or pretty, but you just want to have a visual that is somewhat to scale so that you can understand the data set and it'll help you answer some of these probability questions. So I'm just going to mark the mean at the center and then keep track of the standard deviation. Let's do the same thing for the ACT scores, which are also normally distributed, with a mean of 19.4, and it has a standard deviation of 5.4. Okay, let's take a look at question 1B. In question 1B, we're told that University of Florida accepts students who typically have an SAT score between a 1320 and a 1470. So let's go ahead and use our drawing here and mark it on the normal distribution. Again, it doesn't have to be perfect, but we know that 1320 is above the mean, and it doesn't have to be to scale. You're just giving yourself a visual. So to find the probability of students, or the proportion of students who score between a 1320 and 1470, we're looking at the shaded area under the curve that I've just shaded in red here. And remember, this red shaded region represents all those frequency bars, so all those SAT scores that are between a 1320 and a 1470. If you're using your graphing calculator, you want to use that normal CDF function here. And to find the shaded area under the curve using normal CDF, you need to put in your lower bound. So this would be a 1320. The upper bound goes up to 1470. And then don't forget to put in the mean and the standard deviation for this distribution. So that's a 13, oops. So that is a mean of 1024 and a standard deviation of 229. And when you press enter here, we're going to get an area, I'll write it down here, of approximately 0.0723, so we can round that to about 7.2%. Okay, let's take a look at the ACT distribution. Again, I'm going to use the graphing calculator for this. So normal CDF, and then for ACT scores, University of Florida accepts students who typically score between a 28 and a 33. And again, my drawing is not to scale. I'm just giving myself a visual and reminding myself that that shaded area under the curve is all those frequency bars that represent all ACT scores within that range, okay? And then now let's use normal CDF, put in our lower bound of 28, our upper bound of 33, our mean score of 19.4 with a standard deviation value of 5.4. Okay, pressing enter here, our calculator is going to give us approximately 0.0497, or we can round that to 0.05, or about 5%. Okay. If you're not using your graphing calculator function and instead you're using z-scores in the z-table, then the first thing that you want to do is calculate the z-score for that 1320. So using that formula, x minus mu divided by sigma. The z-score for 1320 corresponds to a z-score of 1.51. Then go to the z-table. That gives you a corresponding area to the left of that z-score of 0.9345. Do the same thing for the SAT score of a 1470. Subtract that from the mean, divide by the standard deviation value. This gives us a z-score of 1.95. Go to the z-table, gives us a corresponding area of 0.9744 on the left. And then if we subtract these two values, you'll see that you'll get an answer that is very close to 7.2%. Do the same thing for the ACT score. Calculate the z-score, 28 minus that mean of 19.4, divide by the standard deviation of 5.4. We get a z-score of 1.59. Going to the z-table, that gives us an area of 0.9441 on the left of that z-score. And then a z-score of, for an ACT score of 33. If we make subtract and then divide by that standard deviation, it gives us a z-score of 2.52, which has a corresponding area of 0.9941 on the table. And then again, if we subtract these two from each other to get the shaded area in between, you should get something very close to 0.05 or 5%.